All right, so this video is for 9-2. So it says Noah put $40 on his fare card. Every time he rides public transportation, $2.50 is subtracted from the amount available on his card. So we need to underline the important information. It's important to know that $40 is on his card. It's also important to know that every time he takes a ride, it's going to subtract $2.50 from the amount available. So number 1 says, how much money in dollars is available on his card after he takes, and then we have a couple scenarios, after he takes 0 rides, 1 ride, 2 rides, and X amount of rides. So if Noah hasn't taken any rides yet, how much money does he still have on his card? Of course, he still has $40 if he hasn't ridden any rides yet. Now he hops on public transportation, takes 1 ride. How much money does he now have on his card?
Teachers and students, please pardon.
Sorry for that. So we're going to subtract $2.50. So 40 minus $2.50 would be $37.50. $37.50. So if he's ridden it 2 times, now he should have $35 because we subtract $2.50 again. Now it asks, okay, but what about X number of rides? So what about for 13 rides or for 11 rides? We wouldn't want to subtract $2.50 every single time. So what could we do? Well, the process that we've been taking is we've taken $40, which was his original amount, and we've subtracted $2.50 times the amount of rides. So X would stand for the amount of rides. So if he's taken 10 rides, we could take $2.50 times X and subtract it from 40 to quickly find out how much money he has left on his card. So number 2 says, graph the relationship between amount of money in the card and the number of rides. So they have number of rides down here on the x-axis and dollars on the card over here on the y. So where should we put our first point? Well, the first situation we had was he hadn't taken any rides yet, and he still had $40 on his card. Hopefully you recognize that that is also our vertical intercept. Our next scenario was he took 1 ride and he has $37.50. Each of these boxes are going to be worth $2.50, so $37.50. 2 rides, he would be at $35. 3 rides, it would go down $2.50 again, so that'd be $32.50. 4 rides, it would go down $2 more and 50 cents, which would be $30. Hopefully you're starting to see a pattern. For each ride he takes, it goes down $2.50. Now guys, we have to decide whether or not we should connect these. So we have to look at the x-axis. Is it possible for us to take half of a ride and only pay $1.25? No, that's not an option. So we would not connect these because we can't have half of a ride. We can't have 2.5 rides. We can't have 4.5 rides. We have to make the entire ride. So then number 3 says, how many rides can Noah take before the card runs out of money? I want you to look at the graph a minute and think about that. How many rides can Noah take before the card runs out of money? Hopefully you figured out that the card would run out of money when he has taken 16 rides. Then it says, where do you see this number of rides on your graph? You should see it right here. So when it says, where do you see this number? Well, we have to tell them where. So we saw it at, this point right here. Well, that point is 16 on the y-axis and up 16 on the x-axis and up 0 on the y. So that would be at the point 16, 0. Hopefully you notice that is on the x-axis. That's down here on the x-axis. Remember that we can look at each point and be able to tell exactly what it means. So 16 represents rides because that's the the x value. So the zero would The 0 would represent the y-axis, which is the dollars on the card. So 0 means that he has $0 left. So 16 rides, at the point 16 rides, he would have no money left. Good. You need to go back and watch any part of that, you can. But at this point, you need to switch to the next video so that you can get your notes completed.